Hello and welcome to the Data Engineering Podcast, the show about modern data management. Introducing RudderStack Profiles. RudderStack Profiles takes the SAS guesswork and SQL grunt work out of building complete customer profiles so you can quickly ship actionable, enriched data to every downstream team. You specify the customer traits, then Profiles runs the joins and computations for you to create complete customer profiles. Get all of the details and try the new product today at dataengineeringpodcast.com/rudderstack. You shouldn't have to throw away the database to build with fast-changing data. You should be able to keep the familiarity of SQL and the proven architecture of cloud warehouses, but swap the decades-old batch computation model for an efficient incremental engine to get complex queries that are always up to date. With Materialize, you can. It's the only true SQL streaming database built from the ground up to meet the needs of modern data products. Whether it's real-time dashboarding and analytics, personalization and segmentation, or automation and alerting, Materialize gives you the ability to work with fresh, correct, and scalable results, all in a familiar SQL interface. Go to dataengineeringpodcast.com/materialize today to get 2 weeks free. Your host is Tobias Macey, and today I'm interviewing Elad Eldor about operating Kafka in production and how to keep your clusters stable and performant. So, Elad, can you start by introducing yourself?
Yeah, sure. So nice to meet you, first of all, and thank you for letting me be on the podcast. So my name is Elad, and I'm a data ops group manager at Iron Source, which is an Israeli company that was merged with Unity. And on my job, I primarily focus on stability, deployment, and cost reduction of big data analytics clusters on AWS, such as Druid, Trino, Spark, etc. And I also am involved with Kafka production issues and cost reduction issues, but mainly in production and stability issues on Kafka. Prior to that, I was an SRE for a company called Cognite, where I was in charge of stability of big data clusters on-prem, for Linux on-prem, mainly for Spark streaming, Spark batch, and Presto on HDFS at various customer sites. Prior to that, I was a Java backend engineer for about 10 years. And I recently published a book called Kafka Troubleshooting in Production, which will be parts of it will be I think, the main topics of what we will discuss today. And it talks about how to handle production issues in Kafka clusters, both on-prem and on the cloud on AWS.
And do you remember how you first got started working in data and what it is about that space that keeps you interested?
So I started working on big data about 7 years ago when I developed my first Spark streaming application, consuming from Kafka and persisting to HDFS on Linux on-prem clusters. Before that, I just wrote, backend applications that were reading from some database, writing from some into some databases, but it wasn't formally big data. And 5 years ago, I understood that on big data clusters, there are production issues that I didn't see before. And so I reverted from being a developer, I reverted to being an SRE and solving stability issues in these clusters, which meant knowing better not my code, but the infrastructure, the cluster that my code or some big data code runs on, whether these are Presto clusters, Spark clusters, Spark batches, Spark streaming, Kafka, HDFS, and it was a whole new world for me, and that's what brought me specifically to handle Kafka issues, which I do for the last like in production, I do it since 2018, but I started doing it a year before. So maybe the question is more what brought me to be not to be a developer anymore, but to become an SRE slash data ops of big data clusters, and specifically focusing on cost reduction, whether on-prem or on the cloud, and uh, and and focusing on Kafka. So I will elaborate on the Kafka issue. So I understood that Kafka is like stuck in the middle of everything. Like if there is a problem with Kafka, your whole data pipeline is just is stuck. Producers can't write, consumers can't read, um, and that's what it was a combination of two things. One, the understanding that Kafka, the best ROI for my time will be to focus on Kafka. And the second thing was that I stumbled into a book called System Performance by Brendan Gregg, who was a lead performance engineer at Netflix, and now he works under the Intel's CTO on distributed clusters. And this really opened me a world of that I wasn't aware of before, of monitoring and detecting bottlenecks in Linux clusters, and not only understanding what's your bottleneck, what's the cluster bottleneck, but also it opened the way to reduce costs. And what I saw when I stumbled into production issues in Kafka, Spark, Presto, Druid, or for this matter, any service, any applicative service on running on Linux cluster, is that understanding how to diagnose issues in a Linux cluster can really help you detect what's the problem in many cases, and also allows you to reduce costs on the cloud.
In terms of the Kafka focus, you mentioned that you were working as a backend developer. You were interested in the use cases for Kafka, the production requirements around it, how to make sure that it was stable and performant. And I'm wondering if you can talk to, at least at a high level, some of the different environments in which you've had experience working with Kafka and some of the categories of operational challenge that you've had to deal with in that process.
Sure. So I started with the on-prem cluster, Kafka on-prem, and it was on a Kafka distribution of Hortonworks, HDP, before they were acquired by Cloudera. So it was a free distribution of Kafka, and and now I work on with Kafka open source on AWS cloud. So in either cases, it wasn't a managed service, so we had to diagnose the issues and solve them ourselves. Now, because both are practically Kafka open source, although it was when I was on prem, it was part of the HDP, but I don't see a lot of difference here. The main issue here was on-prem versus cloud, and this is why my book focuses mostly on cloud deployment, but also on on-prem deployment. So I started from on-prem, and there is a big difference in the in some parts. There are big differences on-prem because you are in charge of the hardware failures, for example. Now, the most common failure for hardware on-prem, no matter which cluster it is, are disks. And in Kafka on-prem, usually you need a lot of storage. And so in order not to pay much, you use HDD disks and not SSD. So they fail for a lot of, the ratio of failure is pretty high, and you need to take care of it because it is not cloud. Another issue is that on-prem environments, you usually the SRE is not on site, so you have a tier one, tier two support, which are usually unaware of signals that can say that something is going to get wrong, something is wrong in the cluster. So as an SRE of on-prem, you reach the problems once the cluster halts sometime. But there are also, but on the cloud, the cloud provider will tell you, okay, you don't need to handle disk failures. However, when even on the cloud, a broker can halt because of disk deterioration, and you wouldn't know of it until you get into legs. But you don't need to replace the disk; you just can replace the broker, which is much easier in the cloud versus on-prem, where you need to get into the drawer of disks and replace the disk. Another big difference is the scaling. If you have more traffic, you can scale out. On the cloud, you can just scale out or scale up, and by spin a new cluster pretty easily. While on-prem, it's very, very tough, because think of it like if you want to scale up, you need to have disks on site, and sometimes you don't have these disks on site. What happens if you ship the cluster to another and your customer is in another country? Other Another issue is like what happens when you need more RAM. On the cloud, you just spin a cluster with instances with more RAM. But on-prem, you need to check that you have enough slots in order to insert DIMM sticks, memory sticks, into the cluster, into each machine, and you need to do it like manually. So I think the scaling, the two main differences are the scaling option, which is much easier on the cloud, and handling failures, hardware failures, which is also when you are the when you're an SRE of on-prem, it's on you or on the first tiers that manage the issue once. But while in the cloud, you just detect the issue. You need to detect the issue and then replace the machine. So these were the two. Like I came from on-prem, not only from Kafka. Like I did only for Spark application. It's pretty much the same issue between on-prem and on the cloud. These two issues. However, the benefit of deploying on-prem is the fact that you don't pay for every hour. You just pay once. And I think today there is a growing discussion whether cloud-based companies, maybe they need to go on-prem for some of their clusters. So it's the math behind this calculation sometimes I think favors on-prem, even though you need to handle this. The scaling is very tough, and it's on you to detect hardware issues, but maybe the cost sometimes justifies this.
Yeah, the on premise versus in cloud debate is definitely ongoing and always very nuanced. And to your point, yeah, where on prem, the cost over time is much lower because you own the hardware, so you don't have to pay a continuous upkeep for it. But there's the opportunity cost of having to move slower and more deliberately, and perhaps reducing the number of chances or experiments that you take because of the fact that it is so much lead time to bring in that hardware and scale up the cluster. And also on the point of Kafka, that's an interesting aspect as well, where my understanding of the way that Kafka itself is designed and some of the aspects of having to define upfront the number of topics in order to accommodate a certain number of clients seems as though it lends itself more readily to that fixed installment on-prem environment versus the cloud environment where you are incentivized to elastically scale up and down. And I'm wondering what you see as some of the challenges of bringing Kafka into the cloud because of that potential for elasticity in the clusters.
I see that the if you don't care about the money, like use the cloud. Okay, the money is the only reason why going on prem, because it's indeed it's tough. But it's interesting that you mentioned that Kafka might sound reasonable, a good candidate to be deployed on-prem. And by the way, there are companies that most of their clusters are that host open source analytics tool or messaging tools are deployed on the cloud, but Kafka is deployed on-prem. I know of two not small Israeli companies that have their Kafka deployed on-prem, and what like from my experience, because I was I was SRE for various customers when I was working for on-prem, so I saw several examples, and the main thing that I saw in the main difficulty that I saw when provisioning a Kafka cluster. By the way, most of the clusters were over provisioned. This is one problem in on-prem, that you over provision because it takes time to purchase more disks or DIMMs or brokers. So it's hard to say what's going to be the size of the cluster. But if I will take one factor that makes it hard to provision upfront the Kafka cluster, is the storage, is the retention, because on-prem you need to remember that most of like people on the cloud that were born to the cloud, let's say, that started working only and they work only on cloud environments, they tend to forget that there are many on-prem clusters, and much of these on-prem clusters are deployed by enterprises or by companies that are not really high-tech, and they have big on-prem clusters. And these customers, the owners of the customer, let's say, they are also the owners of the data center, and you provide them the data center, and they have retention requirements that they serve not only how much time will it take you to recover from lag, but they have, which is usually in cloud and internet companies, that's the retention, several hours. They want days or even a week. So this changes the whole picture, because then when I started when I started as an SRE, I saw clusters that were just a bunch of machines that cost sometimes tens of thousands of dollars, and their CPU utilization is like ridiculous. It's 10% user time, and the RAM usage, well, you never know what's your RAM usage, because we might later talk about the page cache, but it's very hard to understand what's the RAM usage in Kafka. But the disk storage was the utilization usage was really high because of this retention. And then you come to a point, and I dedicated a chapter in the book only for this, to how you, whether you use RAID 1 plus RAID 0, or use JBOD, because I can give a real example of a customer that had 17 brokers, and just in order to satisfy the retention requirements of the customer, and then the customer decided to double the amount of retention, because that's the order that he got. It was some government law enforcement. So you don't mess with them. They tell you, okay, I need to double my retention. So you need to satisfy this. And the first reaction was, okay, let's double the amount of brokers. But then I convinced that my managers that we just need to switch from RAID 10 to JBOD. Now, RAID 10 gives you double the amount of replication. So if you have replication factor of 3, you will get 6 copies per segment if you use RAID 10. But if you use JBOD, then you save half of the disks, and then you don't need to add even one broker. Just use the same number of disks, and if you want even more storage, you can just add more disks. But then you run into the issue of, okay, I don't have enough disks in my drawer, so you need to add another drawer to each broker. These are things that on the cloud you don't even think about them. people on the cloud even don't know about them. But if I will take one thing that is really like that makes provisioning Kafka on-prem to be tough is the retention requirements. And managers for on-prem clusters tend to be very sensitive for retention. They want 10 times the amount of retention or 20 times the amount of retention that internet companies have, for example.
And bringing us around to the book that you wrote, which you mentioned, what was your motivation for bringing this all together in the written form, and what are the overall goals that you have for the book and the people who are reading it?
So back in, I remember myself as a backend engineer trying to deploy my application, my streaming application on Kafka, and going to something didn't work in the Kafka on dev. So I remember going to the DevOps room, and everyone are afraid when you go to the DevOps room because they're the most important, the critical part of the organization. And I asked them, okay, I don't know what's wrong with my Kafka. And they had no clue, and they didn't get an answer because they had no time. And then I went out of the room. I decided that I will know Kafka from all the angles. Like, that was my really initial motivation. But if to be more serious, when I started handling production issues in Kafka, and I went over to sites, customer sites, I saw that people just were clueless about what's wrong with Kafka. They blamed, everyone blamed the other part. The devils blamed consumers blamed producers blamed Kafka. And so I wanted and it is in the middle of the data pipeline. So that was my motivation. The best ROI for my time was definitely Kafka and Linux operating system, like understanding the metrics and how to diagnose, using Linux metrics, diagnose problems in Kafka. After now, was why I wanted to learn Kafka from real production issues. My motivation for the book was that these support engineers and DevOps and developers that encounter issues in Kafka, which is not a managed service, so they manage it themselves, will have a cookbook for understanding, like recipes, understanding how to handle production issues in Kafka. And this is why the book is split into three sections, three logical sections. It's the data section, the Linux OS section, and the Kafka metrics section. And also for most of it cloud-based, but also two chapters dedicated specifically to on-prem, because the some of the problems that I saw on-prem were just duplicated when I was starting to work on the cloud. On the cloud, it's just easier because you have monitoring in front of your eyes. You don't need to get logs from support engineers. But so I saw that there was no book. There was nothing that even resembled a book about real production issues in Kafka, and there is a real need for this, because there are so many Kafka deployments out there, whether on-prem, on the cloud, and people are just I talked to one CTO of a Israeli startup who told me I must use Kafka because that's the message bus today, but it's hell. Okay, managing it is so tough. And I heard it after he said it from different people, different ops managers, or tech leaders at some small companies, and I understood that it's just a common problem. And then the idea for the book, I mean, it didn't come to me. I got an offer to write the book, and then it took me some months because it's a lot of work. Then I decided to compile, to gather all the stuff that I compiled for during the 6 years of me working in Kafka, and that was my motivation. Like, I'm not saying that people shouldn't use Amazon MSK, yeah, or Confluent or Ivan, but I think that for 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 those who already manage Kafka, they should have a better guide than no guide, first of all, and also for those who consider they manage their own Kafka and say, okay, it's tough, it's too much, it's too tough. We need to pay license and move to some managed service. I think that if they have the right guide, then it can save them money. And I work in the open source with open source for 20 years, and like I see this as my small contribution to the open source community.
To the point of saving money and whether to run your own Kafka cluster or use a managed service, there are a lot of considerations that go into all of that, as well as the use cases of what you're going to be building on top of Kafka and what are the sizing and scaling requirements. I'm wondering, for people who are in that position of deciding, do I want to use Kafka? How do I want to use Kafka as far as self-managed or managed service? And what are the parameters along which I need to project what my cost is going to be? What are the different elements that they need to be considering and planning for as they start to evaluate and do those initial deployments?
So first of all, you need to understand your traffic. Okay, so let's assume you are not a small company and that you decide you're at the decision point whether you need to use Kafka first of all, and then if you use Kafka, whether you're going to use cloud managed or you manage it yourself. So regarding alternatives to Kafka, I'm not aware of any alternatives. However, I never search for alternatives because Kafka is just everywhere. So let's say you chose Kafka and you have enough traffic so that you can build even a minimal cluster of three brokers. Yeah. But let's assume you have more, and let's assume you have multiple Kafka clusters per each team or service or a group or whatever. So in that case, first of all, you need to know your traffic, the number of topics per cluster, the number of partitions, and who are your consumers per topic, who are your producers. So understanding the producing rate, the consuming rate, and then you need to provision a cluster. Let's say even before you know whether it's cloud-based or not, you need to understand how much CPU you're going to require, how much RAM in order to support not the Kafka process itself, but the page cache, because you want data to be read from the page cache and not from the disks, and allocate enough disks, cheap disks, in order to support as cheaper as possible to handle the retention requirement. And now, so after you have this estimation and you know how many brokers you have and what's the size of the broker, now it depends the decision whether it's a cloud-based or not. If you are cloud-based, you will usually pick a cloud-based. But again, some companies decide, okay, I will put my Kafka on-prem because I know it cannot be spot instances. But most of the companies which are cloud-based will deploy it on the cloud, and they will deploy it probably on-demand instances if they are on AWS. Some, if they have a strong DevOps team, they will deploy it on Kubernetes maybe. But I don't have an experience with Kafka on Kubernetes, so I can't say anything about it. I also didn't write about it, of course. Um, but and if you're on-prem, you will deploy it on-prem, of course. Now, the question may of whether to deploy it on, like, purchase a license for Confluent or for Amazon MSK or for Ivan. These are some of the managed services, or use it or manage it yourself. It really depends on how your ops team, whether it's DevOps or data ops, know how to handle production issues, and that's ops teams are rare. Good ops teams, I mean, are rare, and uh, and I think that if like you need an excellent monitoring of Kafka. And when I say excellent, I don't mean hundreds of metrics. Okay, I mean a minimal set of metrics that will show you where production issues can occur. And in my book, I have two chapters: one on producer metrics, one on consumer metrics, and three chapters on CPU, RAM, and disks for the broker themselves. So I think like half of the book talks about how to diagnose issues, and from this the reader can understand what to monitor. So you need an excellent monitoring, but not too large. You need like specific monitoring in order to deploy it yourself. Because if you are blind in Kafka, you will pay a big price. You will have downtime and you will just lose data. So you must have an excellent monitoring and a team who knows how to manage the Kafka cluster. And otherwise, choose cloud-based, or there are again, because the knowledge of handling Kafka clusters is pretty rare. What happens is that some places, some customers, and I saw it in on-prem, they just sometimes Kafka halts and they lose data because there's not enough knowledge. That's not like that's not, of course, the situation at my current company. We have an excellent DevOps team, and its team leader was also the technical editor for my book, and he affected a lot on the content and also on how to like at some parts of what to focus. His name is Or Arnon, and I'm very grateful for him that he invested the time to read and to edit the book. But again, it's some companies you have an excellent DevOps team, and some customers you don't have. And if you're willing to lose data at some time, then use the open source. And if not, then go to then pay the license for managed Kafka.
Data lakes are notoriously complex. For data engineers who battle to build and scale high-quality data workflows on the data lake, Starburst powers petabyte-scale SQL analytics fast, at a fraction of the cost of traditional methods, so that you can meet all of your data needs, ranging from AI to data applications to complete analytics. Trusted by teams of all sizes, including Comcast and DoorDash, Starburst is a data lake analytics platform that delivers the adaptability and flexibility a lakehouse ecosystem promises. And Starburst does all of this on an open architecture, with first-class support for Apache Iceberg, Delta Lake, and Hoodie, so you always maintain ownership of your data. Want to see Starburst in action? Go to dataengineeringpodcast.com/starburst and get $500 in credits to try Starburst Galaxy today, the easiest and fastest way to get started using Trino. And on that note of data loss and the cluster uptime and stability, what are some of the failure conditions that cluster operators need to be thinking about that might lead to data loss, and some of the ways to mitigate that and plan for it in order to be able to reduce the time to resolution?
In terms of preventing data loss, let's start with prevention and then go to what can cause data loss. First of all, you have replication. Now, replication goes side by side with the size of the cluster, because the higher the replication factor, then each segment will have more copies on different brokers. However, you will need more storage, and more storage means like more storage means sometimes more brokers, and even if not more brokers, it means more disks. So it will cost you more, high replication factor. Also, you can add another level of assurance and deploy RAID, let's say RAID 10, RAID 1 plus RAID 0, and this will double the amount of storage that you need. So replication is one thing. Making sure that your producer they receive ACKs, acknowledgements from the broker, is another thing, although it may affect latency. Retention policy. Retention policy, it's pretty simple policy, and you wouldn't believe the number of times that consumers lose data because of it, because you can define it by time or by size or by both, and then the threshold is the minimal between both. And if you define it by size, and suddenly the topic size, the traffic increases even by a small amount of percentage, and your consumer lags, then you will lose data, or some consumers will lose data. So if like if the audience will take one thing from regarding retention, is that highly consider configuring retention by time, and not by size, because you really don't know the traffic at any point of time, and some producer can increase the traffic by multiply of 10 because there was some filter and the developer just removed that filter, and suddenly you get 10 times the traffic. However, if again, nothing is simple in Kafka, if you configure retention by time, then you might get into storage, 100% storage. So again, this equilibrium between retention size, retention time, and storage. Again, we reach storage. Hardware failures, monitor hardware failures. Now on-prem, you can just check the status of the disks. I repeat again, disks. This is the most critical, the cheapest part of Kafka, but the most critical part of Kafka, and the cause for many problems. So like on-prem, there are tools that you can monitor the state of the disk, and just a very like a recommendation that can save several clusters, I assume. If a disk becomes read-only, so you can just read and not write, usually it means you need to replace the disk, because even running FSCK on the disk will help maybe for several minutes, hours, or days, but after that it will become again read-only, and producers cannot write to it, and it will create a whole mess. So monitor the disks. On-prem, you have the tool to check its health, and on the cloud you can check the disk utilization. So the iostat tool, the Linux tool called iostat minus X, print every 1 second, can show you that if the disk utilization is 100% all the time, then something is wrong with your disk. Another metric is, there are a lot of metrics, but another one that happens to be around every production issue is the system time, the CPU system time. There are 4 main CPU metrics. You have the user time, system time, IO wait time, which is either disk time, wait time for disk, or wait time for network, and context switches. If the system time goes, let's say, about 10%, then you should suspect something is not good in your cluster. If your context switches time reaches, let's say, more than 3-4%, then check what happens there. A common cause, by the way, to a high context switch time percentage could be that you just have too many disk IO threads compared to the number of disks that you have. And this is if you want, like, if you want to be like very cautious, you can backup regularly your data, either by using the feature of tiered storage of Kafka, which I admit I didn't use until now, or you can just add another consumer and just take the data from the topic and persist it to some cheaper storage like HDFS, where or S3, where the storage is separate from the compute. So this is regarding some ways to prevent data loss. But in order to, but these are the like what happens after you already have a problem. But the question is how you prevent the problems. And from my experience with Kafka in production in the last 6 years, is that Kafka cluster talk before they hint you, before they cripple down. They tell you stuff, and they tell you this through the disk utilization, the IOSTA tool, which you can see using the IOSTA tool. They tell you this using top command. Check the system time, the CPU system time, check the CPU context switch, CPU wait time. If you have GC issues in your Kafka process, then it will tell you this through spikes in the user time during a full GC. You can use the JSTAT tool, which is part of the JDK tools, in order to check for a full GC, the frequency of full GC. Again, it's like this is why half the book talks about, half the chapters almost talk about how to, like, various cases that they stumbled upon regarding what can lead you to data loss. I had a colleague asking me. I gave him a copy of the book, and he asked me, okay, well, but you didn't talk about the issue of unreplicated partitions. And I replied to him, well, every problem in Kafka can result in under-replicated partitions, or in partitions that are not, they don't appear in the list of in-sync replicas in the ISR. So, and there are tens of problems which might not even be on the Kafka itself. Like, it could be in the operating system, because something is, like, sometimes it's even not in the Kafka. Again, like, if you deploy another service, if you deploy a antivirus, or firewall, and they scan the segments all the time, and you will have high disk utilization, this is not the fault of Kafka, but it will cripple down your Kafka. So, and there are some, I saw on-prem clusters where you shut down the firewall and then it comes up again because of some policy. So you need to remember that not always you run alone on the broker, but asking, like, how, like, what can cause data loss is like is like asking what should I monitor in Kafka, and how to deal with it, and that's the topic of the book in general.
And given your experience both working as a backend engineer and operating Kafka clusters at scale, I'm wondering if you were to be in the room today redesigning Kafka from the ground up, what are some of the aspects of the system design that you might choose to revisit or revitalize?
Uh, I think the design is makes a lot of sense. The log-based approach. I don't have many changes. I don't think of any change other than one change, which is for me it's a bug. I don't know if they declare it as a feature that they spread. If you have more than one disk, then the partitions are being spread among the disks, given the number of partitions per disk, and not given the amount of storage per disk, which I don't think that the Kafka community understands how it affects some Kafka cluster owners to decide whether they go RAID or JBOD. It's like something that if it will be fixed, the amount of cost that will be saved for disk and maybe for cluster will be pretty big, because there are ops teams that say, okay, I don't want to go JBOD because of this. I don't want to handle the spread of the data among the disk. But other than this feature slash bug of spreading the data evenly according to storage and not number of partitions, uh, I must admit that I'm not in the applicative side anymore for a long time, because to be honest, it interests me much less than the ops side. So my focus is on the ops side, and then it comes down to like this question comes down to like it could be asked regarding every big data cluster, but in Kafka, it's really hard to understand the root cause of production issues. To be honest, I don't know why fix a problem in Druid or Spark or Spark Streaming or Trino takes much less time than understanding why data was lost on Kafka, or why the disk utilization is so high. I don't fully understand it, but like if I take the amount of time that I invested in every Kafka production issue compared to other cluster, it will be, I'm not kidding, like 10 times, between 5 times and 10 times more. So I think that, and this brings me back to the motivation of writing the book, that Kafka uses the operating system in a way that no other open source that I know of uses it, especially not the CPU, by the way. It's really like on the CPU, it's like very simple user time, and that's it if you do it correct. But the usage of the page cache, the trashing of the page cache in cases that you have legs, and the amount of stress that comes down on the disks is something that I don't think the those who created Kafka, or those who develop it or contribute to it, I think there's some split between those who develop and those who maintain, and and there is not enough connection between the two sides, and maybe this is another, when I think of it, I'm thinking out loud now. This is another reason why the book is important, both for developers and for ops team, in order to not only understand Kafka, but also understand, for developers to understand the ops team, uh, because there are so much problems that are being caused by one disk that goes rogue. One disk. You can have a cluster with tens of disks, and one disk go bad, and this can cause the whole cluster to halt. And a healthy cluster should not suffer from such an issue. I remember getting a call about 5 years ago from a customer side that had 3 brokers, 6 disks, HDD disks, configured in RAID 10, and one disk went bad. So you see, but in RAID 10, in RAID, you see only one logical disk. So, and the utilization in IOSTAT shows the utilization of the highest utilization among all the disks in the RAID, and then you see 100%. So I guess that it was one machine, one disk that was that got screwed, and I told the support engineer, go to the room and check if the light waves on one of the disks, and he told me yes, there's the light waves of one of them. But imagine that you need to do I needed to guess this because of the lack of monitoring. So when I think of it, then the work on something needs to change on, like, not on the work on the disk, because this is what Kafka does. It writes massive amounts of data to the disk, and it tries not to read from the disk, but at many customer sites or cloud or cluster, it reads from disk. And first of all, ops team don't know it reads from disk. Secondly, like, many clusters have deployment of RAID. So how can you assist them in understanding that one disk got screwed? They don't have, and in the cloud also, by the way, why when one disk gets bad, there is the cloud provider won't tell you that, because they can't really tell you, okay, I'm on the disk is on 80% utilization for 30 minutes, we don't know if it's good or not, so we will not tell you anything. And then you get into high IO8 and you replace the broker. So the mitigation for disk issues in Kafka is brute force, and figuring out that you have a disk issue, you need to be a magician in order to know this, and developers of Kafka just assume that okay, someone will handle it. It's not us. We just develop. And I think that for me, I did a career shift, which is not common, like going from developer to ops. So I understand the frustration from both sides, and I think that there should be more people that know both paradigms, and because a lot of production issues originate from the lack of understanding or the lack of cooperation or knowledge sharing between the two. If the Kafka community had better communication between the developers and the ops team, then I think it would be much easier to detect disk issues, which cause, I bet it causes like at least a third of the problems in Kafka.
Yeah, it's definitely always a challenge balancing the developer of I just want to get something shipped and do something cool with some fancy new feature, and the operations team of I just want you to stop crushing my machines so that I can sleep at night.
Yes, but it's like in the Kafka community, I think there is a lack of ops team that will check these developments, and but it's not even new development. Just I'm asking the Kafka community, like, go to deployments and of Kafka and check, ask customers what's the percentage of production issues which is caused by disks, and then try to, I don't know, maybe every Kafka tool needs a better monitoring of disks, like and also if there is monitoring, how do you read, like Brendan Gregg has an excellent explanation of how to read IOStat, the output of IOStat. So you have the utilization, like the service time is obsolete. No one needs to look at it. So you have utilization, you have throughput, which is the read megabyte per sec and write megabyte per sec, and you have IOPS, which is the read per sec and write per sec. And 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 this is a fact that not many people know. The saturation of disks is 60%, only 60%, which means that every increase in the disk utilization is bringing the situation, the level of IO8 will become worse and worse and worse. And it's not like in CPU. In CPU, it could be like the recommendation on cloud is like 75% CPU saturation. Above that, your load average will increases in a non-linear way. So how do you read how Kafka use ops team should read the output of IOStat? Well, it's simple. Look at the disk utilization. The disk utilization of 100, I saw developer ops team telling me, okay, we reach 100%, this is not good. No, this is okay, because Kafka works in bursts. So it writes a lot of data for a small amount of time. So we'll have high disk utilization caused by write megabyte per second, write per sec. This is good. And then you should see 0. And then again, you have a burst of writes. But if you have if you have 100% utilization because of reads, then it means that you read from the disk, which means that you have a problem somewhere. Maybe you have a consumer lag, maybe you replicate a broker that replicates the data is lagging behind, which means that this partition is not in this broker is not in your ISR list of this partition. So just look at the output of the IOStat -X that prints every 1 second. And if you have several seconds of 100% utilization from writes, then this is okay. But if you have the same 100% utilization from reads, then this is not okay. Now, if the community will take this and make it an alert or some monitoring tool, then it will reduce, and Opsteam will know how to read this, then it will reduce the frequency of production issues. It is more than 10% for sure. Just this feature, detect lags by looking at the diostat.
And in your experience of working with Kafka clusters and helping customers and end users manage and ensure their uptime, what are some of the most interesting or unexpected or challenging production problems that you've had the opportunity to diagnose?
Okay, I will tell the most. This is the most bizarre. I will tell the most bizarre production issues, but the most interesting one. So the most bizarre, I already mentioned it before, was a cluster of 3 brokers, 18 disks, 6 per broker, configured in RAID 10. That one disk, 140 disk crippled down the cluster because it was on RAID 10. So in fact, only 2 disks were up, and the disk utilization was already pretty high. So it just added to the party this problem, and then I had to guess that one disk was faulty, and this was the support engineer really saw that one disk was faulty after he went to the server room. And of course the other, it's twin disk, because of its RAID 10, also didn't function. And so on that, and the disk utilization was already very high, so it brought the disk utilization to 100% on the broker. So third of the leaders, partition leaders, were on that broker, and then producers stopped, couldn't write to them, consumers didn't read from them, and once consumers don't read even from one partition, then they just cannot function. It depends, of course, on the nature of your consumers, but this was a streaming application that had to read from all consumers, so it got stuck. Even if it wasn't an application that needs to read all consumers, then you have partial data. So that was a very bizarre problem that combine on-prem and high disk utilization and guessing that one disk is faulty. The most interesting problem that I ran into was it took several weeks, I think, and it involved brokers that from a certain point in time, every broker that was added to the cluster due to some failure of other broker, every broker was got at some point to 100% disk utilization, and and nobody managed to write and read from it. Of course, nobody managed to write, so there was nothing to consume. And every time we replaced this broker with another broker, and again the same phenomena happened. And then again, looking from the iostat, after a long time of trying to understand what is going on here, it was like voodoo. We noticed that at some brokers, the disks reach 100% utilization with because for all the time they were on 100% utilization, because they but when we looked at the throughput, we saw that they are half the throughput of the throughput that causes other disks on other brokers to be on 100% utilization. So not only did the healthy brokers reach 100% utilization for small amounts for a few seconds, and then the utilization went down, these brokers with faulty disks reach 100% disk utilization, and it kept 100% utilization, and while the throughput was half. So just correlating the disk utilization with the throughput and the amount of time the disk utilization was 100%, led us to the understanding that these are just faulty disks. But this took a lot of Excels and experience and just checking, trying to correlate every OS metric until we found it out, and that was by far the most interesting production issue that I stumbled into in Kafka.
And in your work of writing the book and consolidating all of the information and experience that you've had working with Kafka, I'm wondering if there are any insights that helped you gain or any new knowledge that you were able to obtain in the process.
Of course, yeah, because mainly like from there were two issues like it helped me formulate the three legs that Kafka stands on. Kafka Ops needs to understand, let's say, which is the data part, the OS part, and the Kafka part. I was surprised to see that the Kafka part is only third of the book, which shows how much the data part is important. How how the way that the data is spread among the partitions is so important for the health of the cluster. And also I was surprised of how many issues, production issues, originate from a problem with storage. And uh, and also I found out several producer and consumer metrics that were new to me, because I thought I, that many issues can be fixed with tuning the linger and the batch size on the producer, and that found out several very important metrics in the consumer and producer. So this was also new to me. I ran across them during the time, like from production issues that I dealt with during the time that I wrote the book. And I must say that a lot of things written in the book were not things that only I discovered. So I worked with several people that we worked together and found the issues together. So in part, it was just documenting what a team of ops people found out, including me, but also other people. I have like in order to make this more specific, I have for example the issue of the storage, just to emphasize. When I wrote the part of the storage usage, it turns out that it's more vast than what I thought of. So if we just take this issue, the storage usage issue, so for example, running out of disk space due to retention configuration. What happens when you configure both time-based and size-based? Uh, the way the option there is an option to lose data, and I was surprised to see how two simple configurations like this can cause data loss. And so retention policy and its effect on the data loss, the explaining like how to add storage to a cluster, how it differs between on-prem and on the cloud, the fact that when you're on-prem, this is not only a technical decision, it's also a managerial or financial decision, because you can't tell the owner of the data center, okay, I had a mistake, I don't need the 2 terabyte disk, I need 4 terabyte disks. So I need to throw away all the 2 terabyte and buy 4 terabyte disks. So it will not go smoothly. So understanding these aspects, like this chapter became partially technical and partially how as a provider for an on-prem customer, how you manage this issue or again in DIMMs, it's the same issue. Okay, it was a mistake. I bought 16 megabyte disk, 16 gigabyte. I need 32 or 64. How do you pass this decision? How do you mix DIMMs in on-prem? And also the effect of the retention on data replay. Sometimes you need to replay the data because you did some wrong transformations. So what's the effect of like custom ops team need to understand that they need storage also for replay. The data skew, how data skew can affect data loss, even if you have a lot of storage. If you don't partition the data correctly, then you will get data loss at some point, even one partition. And it's for certain consumers, this is like data loss in all partition. You need to replay the data again. So the data aspects were also something that I learned along the way. So this is only an example of one chapter, the issues discussed in the chapter of storage usage. But not only that I learned during the writing the book, I think that if I wouldn't write the book, I would forget almost everything. So for me, the personal benefit for me is that I know, I remember stuff, Kafka related stuff that I knew, and I didn't forget them, but also that I learned along the way. So I think the investing 10 months during the weekends, every weekend for this amount of period to write the book was beneficial for my technical knowledge. Absolutely.
Are there any other aspects of the work that you've done with Kafka, your work on the book, the overall Kafka operations ecosystem that we didn't discuss yet that you'd like to cover before we close out the show?
I think we covered a lot of technical stuff. We can discuss the cost reduction, but in very short, like I would like to mention that there is a chapter on cost reduction in Kafka, but it relates to, like, I brought 6 real world examples of cluster that I stumbled upon, which per each example I write how much I specify how much CPU, RAM, and disk each cluster has, and also the usage of each of these resources. And then I ask whether the cluster can be scaled down or scaled in. And then I discuss other metrics, monitoring metrics, and by correlating these Kafka monitoring metrics and the operating system metrics usage, I give recommendation regarding whether you can scale in or scale down the cluster. And I think, like, this is like the the cost of the Kafka cluster. It's not big, I think, compared to other clusters in an organization. But because for cloud based, I assume that most of the deployments are on demand. So even if you have a reservation, again, it's on demand, it's not spot. So it's important, especially in today's market, to squeeze in every penny that you can save. So the cost reduction part is something that can help to reduce costs on Kafka. But there is a part that I didn't talk about, which might be a bigger part even than the machines themselves, which is the data transfer between consumers and brokers. Because if you don't configure, if there is no rec awareness in the cluster, then consumers will read data only from leaders, and these leaders will most of the leaders statistically won't be in the same AZ, and for some companies this can save hundreds of thousands of dollars per year configuring rec awareness. But since I don't have an experience with rec awareness, I didn't discuss it thoroughly. But for those who listen, checking if you can configure rec awareness in your consumers and producers, consumers and brokers, sorry, this can be beneficial. So you need to check your data transfer cost. and maybe it's worthwhile for you to invest in deploying and testing and validating the track awareness works, and then you will read not from the leaders but from the closest replica and save data transfer costs.
Yeah, that can definitely be a substantial cost when running in the cloud, and that's always one of those surprise gotchas when you're first getting up and running in a cloud environment.
Not only when you're getting started, but also when you're after years, then you see the data transfer. Yeah, this brings us back to what we started with regarding cloud versus on-prem. There's the amount of reasons why it becomes like, I don't know, like for some clusters it might be a good idea to check the like I'm saying it is because I came from on-prem, so it's not Chinese for me. And okay, so you don't have managed services, but it might be from the financial perspective a valid choice for some clusters to be deployed on-prem.
All right. Well, for anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as the final question, I'd just like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
Or also, I usually work with analytics clusters, and I think that if there was a tool that would show at any given point of time a correlation between the traffic, whether it's the incoming traffic or query load, so correlating between the load on the cluster and the usage of the cluster in terms of like CPU, RAM, disk, or even internal usage. For example, let's say a Druid cluster that uses, sometimes the bottleneck is the number of workers, or for Trino cluster, it's the number of split queries. So if there was some tool that would show correlation between the load on the cluster and the real usage and cost, it would allow ops teams to better understand whether they can save cost on the cluster, whether they can scale it down, or maybe replace on-demands with spots, or maybe replace on-demand reservation with on-demands without reservation, and then auto-scaling them. So some tool that will show correlation between usage, applicative usage, and resource usage, and will enable to save costs, because especially today, in today's economics, it's becomes pretty important to save costs.
All right. Well, thank you very much for taking the time today to join me and share your experiences of running and operating Kafka clusters and the work that you've done on the book to make that easier for everybody else to do as well. It's definitely a very challenging and necessary task. And as you said, Kafka is very widely deployed. So I appreciate the time and energy that you put into sharing your hard-won knowledge with everyone else. And I hope you enjoy the rest of your day.
Cool. Thank you very much. Again, thank you for hosting me. And I hope that the audience will gain something from this podcast.
Thank you for listening. Don't forget to check out our other shows, Podcast.init, which covers the Python language, its community, and the innovative ways it is being used, and the Machine Learning Podcast, which helps you go from idea to production with machine learning. Visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.